Hello friends, today this is the second part of Unit 5, which is state space modeling. In the first part, in the previous video, we have seen what is state space, what is state space model, and in that we have seen what is state equation, what is output equation. We have also seen what are the advantages of state space technique, and we solved a problem on constructing a state space model for an electrical network. Now in this video, we are going to see how to construct a state space model for a mechanical system. So if you have not gone through the part 1 video, I suggest you to first go through that video before proceeding with this, because that will help you to understand this video better. Okay, now I'm taking the simplest example of a mechanical system where the question says construct a state space model for the mechanical network given. So in the unit 1, we have seen developing a mathematical model for a mechanical system. So this is a simple MBK system where we have one M, one K and one B. So as we know, the state space model will have a state equation and output equation. The state equation is basically of the form x dot is equal to ax plus bu, where x is a state vector. So what is state vector? State vector is a vector which consists of state variables. Now how do we define the state variables? The state variable is a minimum set of variables of the system with the help of which we can develop or we can determine the values of any other variables of the system at any point of time t. Okay, now for this we need to construct the state space model, and in the previous video we have seen what are the hints or the guidelines for selecting a state variables. Now basically for electrical or a mechanical system, so we consider the outputs of energy storing elements of the mechanical system as the state variables. For example, in electrical network we have seen if there is one L, that is inductor, and one capacitor in an electrical network, so we understand that there will be at least two state variables. In the same way, for a mechanical system, the energy storing elements are mass M and spring K. So the number of state vectors or state variables of a mechanical system will be equal to the number of energy storing elements. That means how many M's and K's are there in the system. Okay, now in this, if you consider this system, so we have one M, one B and one K. So how many number of energy storing elements? One M and one K. So one mass and one spring. So there will be two state variables. Okay, so I repeat, the number of energy storing elements will be equal to the number of state variables. So in this system there is one M and one K. So together there are two energy storing elements. Therefore we will have two state variables. And one more thing to identify here is, so see the question says construct the state space model with displacement x as the output. So it is very important to understand what is the output parameter that is expected. The input, you know that. So the force F is the input. So output may differ based on the problem statement. So it is important that you identify what is the output variable that is specified. Okay. So here the first step is to identify the inputs and outputs. The input is, there is one input, that is force, and there is one output, that is x. X is the displacement which is mentioned to be taken as output in the problem statement. The next step is to identify the state variables. So as I said, there are number of energy storing elements. There are two, K and M. So the two state variables will be there. Now, how do we choose the state variables? Now, in case of electrical network, it was simple. Now, here also, we always choose the state variables. So if you remember, for inductor we consider the current flowing through the inductor as a state variable, and for capacitor we consider the voltage across the capacitor as its state variable. Now in case of a mechanical system, always choose the displacement and its first derivative. So what is displacement? That is, there is only one displacement in the system, so x, and its first derivative is dx by dt. So what does the first derivative dx by dt indicate? It indicates a rate of change of displacement, which is velocity. The second derivative would be d square x by dt square, which will be the acceleration. But now when you are choosing state variables for a mechanical system, always choose displacement. If there is one displacement, yes, one displacement. If there are two displacements, two displacements. So always choose displacement and their first derivatives. So in this case we need two state variables, so I'll choose x and dx by dt as my state variable. Okay. So the next point, now what do I do is I name the state variables as z1 and z2. Now for ease of understanding, we follow this notation for all the problems so that there will be an uniformity in solving the problems. So if you understand this problem clearly, you can solve any kind of problem on mechanical system. Okay. Now I choose z1 and z2 as my state variable. So what are the state variables? Z1 is equal to x and Z2 is equal to its first derivative, that is dx by dt. Okay. Now I calculate dz2 by dt as what is a differentiate on both sides. You have this equation z2 equal to dx by dt. So if you differentiate on both the sides, what do I get? Differentiation of z2 as dz2 by dt. And differentiation of dx by dt is d square x by dt. Okay, so this I am doing it because it is required further. And what is output variable? Output variable is y, and as it is given in the question that take the displacement x as the output variable. So that is x, which is nothing but x z1 as per our selection. Okay. Now I am repeating. So the state variables, I choose it as x and dx by dt. I name them as z1 and z2. And just for our benefit in the further problem, so I just differentiate this z2 to get this. So you need to remember this equation. Okay. Remember, or you may need to refer to this equation further. What is the next step? The next step is to draw the free body diagram. So this you have already learnt in the first unit, that given a mechanical model, so how do you draw the free body diagram? So here it is, there is for each displacement, so I just repeat so that you will be able to recall that. So for each displacement there will be a node. So there is one displacement which is called x, so therefore there will be one node, and all these m, b, k are associated with a single displacement, so they are all connected to ground, and there is one input, that is f of t. To better understand this, I'll just scroll up. You can see here there is one mass, therefore one displacement. So one displacement, therefore only one node, and each of these elements are associated with only one displacement, therefore they are all m, b, k, all are connected between the node and the ground. Now the next step is to find the state equation, which is x dot is equal to ax plus bu. Now what is x? X is a state vector. So state vector is nothing but the vector formed by state equations. What are the state equations that we have decided? That z1 and z2. The values we know that. And x dot is the differentiation of the state vector. So for z1 dz1 by dt, and for z2 dz2 by dt. Now our task is, and the u is the input is f of t. Our task is to find the matrices A and B. Now what is output equation? Output equation is y is equal to cx plus du, and x is again z1 z2. Y is the output, which is x, sorry, it has to be x here, sorry, x is nothing but z1, right? The output is x as per the given statement, and we represented x as z1 and dx by dt as z2. So therefore y is z1, and u is again force, that is f of t. Now our task is to find all four matrices A, B, C and D. Now the next step is write the equilibrium equations for the mechanical system in terms of state variables and inputs. So if you observe here, the state equation is ax plus bu, which is in terms of x and u, and output equation is in terms of cx plus du, again it is in terms of x and u. X is nothing but state variables and u is input. Therefore we need to get the equations in terms of either state variables, that is z1 z2, and the input f of t. Now you already know how to write equilibrium equations for the mechanical system. Now there is only one node, so you'll get only one equilibrium equation at the node x. For each of the node you get one equilibrium equations. So if you go back to this, for x node it is associated with three elements m, b and k, and the input f of t. Now for m, the force exerted by mass m is m d square x by dt square. For k it is k into displacement, that is k into x, and for b it is b into dx by dt. Now the same thing is written here. Now f of t is, if you observe this equation, f of t is equal to m d square x by dt square, b into dx by dt, k into x. Now what is said? You should write these equations in terms of state variables. State variables are nothing but z1 and z2. Now as you remember that x is represented by z1, dx by dt is represented by z2, and d square x by dt square. So this is why I was telling that we need to differentiate that. So let me show you that. Remember this equation? So d square x by dt square is nothing but dz2 by dt. So this is why we kept it ready, so that we can substitute this in the equilibrium equation. So d square x by dt square is nothing but dz2 by dt. So going back to the equation, so f of t, now we have got the equation in terms of state variables m dz2 by dt plus b into z2 plus k into z1. So as I said, write the equilibrium equation in terms of state variables and the input. So we don't have any other terms here. So m, b, k are the constants. The variables are only the state variables and the input z1, z2 and f of t. Now what we want? We want the state vector. Sorry, state equation. So if you come back to this, observe the state equation. State equation is nothing but x dot equal to. That means x dot is either dz1 by dt and dz2 by dt. Now we should try to get the expressions for dz1 by dt equal to something and dz2 by dt equal to something. Okay. Now here, come down. So in this equilibrium equation, I have dz2 by dt. Now rewrite the equation. So keep this on the one side, bring the remaining terms on the left hand side. So simplify this for getting a expression for dz2 by dt, which is the equation you got. So this is the equation. So I am marking this as equation number 1, which is for dz2 by dt. Now what is our next task? We need to find an equation for dz1 by dt, right? Now how do I find that? So I know that z1 is equal to x, yes, and z1 is differentiate on the both sides. So I need dz1 by dt. So I get dz1 by dt is equal to dx by dt. So what is dx by dt? We have already decided that we are taking dx by dt as z2. So I can rewrite this as the last equation, dz1 by dt is equal to 0 into z1 plus 1 into z2 plus 0 into f of t. So why did I write it this way? So my original equation is dz1 by dt is equal to z2. But I need to write my equations in terms of all the state variables and the input in a proper order. So all the equations you write it in a way to get the expressions. First write the coefficients of z1, then write the coefficients of z2, then write the input. So if you observe the first equation, here also we have got first z1 coefficient, then z2 coefficient, then f of t, right? So whatever equilibrium equations or any mechanical model related equations, you write them and rearrange them in the proper order. So first write the coefficients of all the state variables in order, like suppose z1, z2, suppose there are 4 state variables, z1, z2, z3, z4. Then at last the output. This is important for getting the state equation, and the LHS should be the differentiation of the state variables. Our state variables are z1, z2, so the LHS should be dz1 by dt and dz2 by dt. Now these two are the important equations that will help us to get the state equation. And what I am doing is the same equation whatever we had got here, equation number 1 and 2. So first I am writing dz1 by dt, and then I am writing dz2 by dt. So go back to the equation. What is state equation? X dot is equal to ax plus bu. Now the first square, dotted square, will tell you that it is of the form ax, and the second dotted rectangle will tell you that it is of the form b into u. Now write the same equations in matrix form. Now what do you get here? Here it is important that you write the equations in a proper format. z1, z2, again z1, z2. So here it is input u, input u. Now write all these coefficients in the matrix form. So observe the ones which I am circling. Now these are the coefficients that you should write it in the matrix form. 0, 1, minus k by m minus b by m. And the state vector is z1, z2. So again, if you observe here, the coefficients of f of t are 0 and 1 by m. So 0 and 1 by m is written as a matrix. Now here you get the two matrices. So this is matrix A, and this is matrix B, and this is X, and this is U. Now you have got the state equation of the form x dot is equal to ax plus bu. What is x dot? Differentiation of the first differentiation of the state variables. Next thing is to get the output equation. Again write the output equation again in the form of the state variables z1, z2 and the input. So follow the same order, z1, then z2, then f of t. So here y is equal to z1. If you remember, if you go back, what is y? Y is the output. Output is x because it is given in the question. X we have named it as, or we have indicated with a state variable z1. Therefore y is equal to z1. So write it in terms of all the state variables. The coefficient of z1 is 1, coefficient of z2, there is no z2 term, so I am giving it a coefficient of 0, and inputs, that is input is f of t and there is the coefficient is 0. Now I can rewrite this output equation. So write the coefficient of z1 here, write the coefficient of z2, that is 0 here, and this takes the form cx plus du. So in place of C I have the matrix 1 0, in place of D I have the single number, that is scalar 0. So this is the output equation of the form y is equal to cx plus du. Now let us see another example. So as we have already seen the first example clearly, so I'll just glance through this on the important parts of this. Okay, now what does it say? This is the mechanical system given, and take the displacement x2 as the output. So it is important that you know that what is the output mentioned. So as it is given that x2 is the output, you should take x2 as the output. Let us see the mechanical model, how it is looking like. So there are two masses m1 and m2. m1 is associated with the displacement x1 and m2 is associated with the displacement x2, and the input force F is applied on the mass m1. So as in the question it is given that x2 is the output. Suppose x1, if you consider x1 as the output, the state equations will be different. For x1 as the output, the state equation will be different, and for x2 as the output, the state equations would be different. Now the first task is to find the inputs and outputs. We have considered f of t as the input and x2 as the output as it is given in the question. The next task is to identify the state variables. Now state variables depends on the number of energy storing elements, as I said before. So how many number of energy storing elements here? So m and k. So I have m1, I have m2, I have k2 by 2, I have k2 by 2, I have k1 by 2. Now here the k2 by 2, the important thing here is to observe it is k2 by 2 and k2 by 2. I'll show it again. There are two spring elements. K2 by 2 and k2 by 2. That means the effect of k2 is spread into two parts, k2 by 2, k2 by 2. Effectively, it is the effect of the spring value k2. It is distributed on either sides equally as k2 by 2 and k2 by 2, but effectively it gives an impact of only one spring. So these two things you consider it as one, and this is another energy storing elements. So two spring elements and two mass elements. So therefore you should have 4 state variables. Okay. Now how do you choose the state variables? We always choose the state variables as displacements and their first derivative. Now what are the displacements? x1 and x2. So these two will be the state variables, and their first displacements, that is dx1 by dt and dx2 by dt. So those will be another two state variables. Now here I come down. So here you can see the statement effect of spring K2 is split as K2 by 2 and K2 by 2. So therefore there will be 4 state variables, x1, x2 and dx1 by dt and dx2 by dt. So I name them as z1, z2, z3, z4. So here are the state variables z1, z2, z2, z3, z4. So it is important that what notation you have used for each of this. The notation doesn't matter. You can take z1 equal to x1 and z2 equal to x2 and the differentiations as z3 and z4. That is also fine. So here what is taken? Z1 as x1 and its differentiation as z2. Z3 as x2 and its differentiation as z4. But this order the notation what you use, sorry, here the notation what you use, so you are choosing this as z1, you can also choose this as z2, not a problem, this as z3 and this as z4, not a problem. Okay, but it is important that you choose these four parameters as the state variables. So in the previous video I had told you that state variables need not be unique. It depends on different whoever is the engineer working on it. So I am choosing as these as the state variables. There may be the other set of state variables also, but what I am suggesting you in this is the easiest way to understand and construct the state variable in a faster way. Okay, so if you choose some other parameters as the state variables, you will still be able to get the state model, but maybe you will have to put more efforts and you will have to it might be time consuming. So the easiest way is to choose the displacements and their first derivatives as the state variables. Now one more thing to observe here is the input u of t is f of t and the output is x2 of t, because it is x2 is given in the question. Next, now here I am keeping some more variables ready because they are required further. So z1 is taken as x1. So the first differentiation of that is dx1 by dt is dz1 by dt. So dx1 by dt is nothing but z2. So therefore the first differentiation of z1 is nothing but z2. Similarly, the first differentiation of z3 is nothing but z4. Now why it is required? We need the state equation, which is of the form x dot is equal to ax plus bu. X is nothing but z1, z2, z3, z4. X dot is the first differentiations. That means our agenda is to find the first differentiations of all the state variables, that is dz1 by dt, dz2 by dt, dz3 by dt, dz4 by dt. So out of those we have already got dz1 by dt and dz3 by dt. Now our task is to find dz2 by dt, the remaining two differentiations, dz2 by dt and dz4 by dt. Coming down, now this is the mechanical model free body diagram, two displacements, two nodes. So M and B are associated with only one displacement, so they are connected between the node x1 and ground. Now these three elements are associated with the displacement x2, so therefore connected between x2 and ground. The k1 is between nodes, or it is associated with the two displacements x1 and x2, therefore it is connected between the nodes x1 and x2. So I'll just scroll up and show you. So you can see here K1 is between M1 and M2. K1 is connected between M1 and M2. Therefore, it is associated with two displacements x1 and x2. That is why we have drawn K1 between the nodes x1 and x2. Now, the next step is easier to find write the equilibrium equation for node x1. This is the equilibrium equation. You write them in terms of z's and f of t. Now, do the substitutions. Now get the expression for dz2 by dt. As I said, you write the expressions with all the state variables in order. So here z1 first, then z2, then z3, then u, that is f of t. Next, for x2, this is the equation. Now again rearrange them to get dz4 by dt. Now